All right, guys, we'll go ahead and get into our section of notes for today. This is going to be 7.1 angles of polygons. And one other thing I will have you do, if you have not already, is in your notebook, I do want you to label our new unit. So we're moving on from triangles. We are getting into unit 7. And specifically, we have a focus here. We're basically just adding on one more side because we just spent 2 units talking about triangles, and now we're talking about quadrilaterals, so 4-sided shapes here. Okay, date today, or date that we did this, is the 29th, if you'd like to add that as well. And our objective for today is we're just talking about polygons, or in other words, shapes as a whole, with specifically their angles. Do I know information about angles, not just with, like we said, we talked about information with triangles, but now can I expand on that with any shapes in general? Okay, so first off, we're going to get into this. We need to understand what I say, or when I say a polygon, what that means. Okay, a polygon is simply just a closed figure. Okay, a closed figure with a certain amount of sides. Okay, a closed figure with a certain amount of sides. That's all a polygon is. So whenever you hear that word polygon, really all you need to think of is it's a shape, some kind of shape. Okay? All right, and then a regular polygon, if we're specifically talking about that, a regular polygon is a polygon whose sides are all congruent. Okay, a regular polygon is a polygon or a shape whose sides are all congruent. So for example, we've actually seen one of these already when we talked about equilateral triangles. That would be an example of a regular polygon. Okay, remember for today, our goal for this is to talk about the angles inside these polygons here. So I'll give you a sec if you'd like. I want you to sketch these 3 shapes for me here. Okay. Okay, so if I'm looking at these 3 shapes here, my goal for these 3 is I'm going to try to figure out what all the angles in these shapes add up to here. So the first one here, I'm going to go ahead and mark the amount of sides here. Okay, and remember this is a triangle, right? 3-sided shape, simple enough. And what do the angles in this triangle add up to? Well, we've talked about that a bunch, right? Those all add up to 180. Okay, so that one's simple, that one's done. Okay, and I'm actually going to go ahead and make a table with this as well. I'm going to say sides. I'm going to say sides here, and let me actually give myself some space here. We'll go sides right here. Okay, how many sides does it have? And then I'm going to say another thing here. We'll say sum of angles. Okay, sum of angles. So we had 3 sides there, and our sum of our angles, we know triangles are always going to be 180. And I'll include the middle column in just a second here. Okay, we just got 3. Okay, next one here. Let's look at what it looks like, what we will eventually talk about, looks like a parallelogram. First of all, how many sides does it have? It has 4 sides, so I'll go ahead and mark that in my table here. And then if we want to know how many, or what the angles are all going to add up to in a 4-sided shape, remember we haven't talked about this yet. The only thing that we've talked about is what the angles in a triangle add up to. So here's the good news, is if I actually take this, I can actually cut this into 2 triangles. I'm just going to cut it, and let's try a better line than that. Okay, I'm going to cut it right down the middle basically, and now I have 2 triangles here. And I know these would add up to 180, and these would add up to 180. So in total, how much is this going to add up to? Well, 180 plus 180 is going to be 360 here. Okay? And really what we're focusing on, since we only know what the angles in a triangle add up to, is this middle column here is going to be number of triangles. This middle column here is going to be number of triangles. So for the first one, when we were dealing with this here, okay, how many triangles were there? Well, there's just 1 triangle. Okay. Next one here, how many triangles were in the next one? There were 2. Okay, and then we'll do the last one here. So we see we now have a 5-sided shape, and this is what we call a pentagon. And we're asking the question, what do all these angles add up to here? Well, again, if I look at this, I can't, I don't know what all of them add up to because we haven't been told about a pentagon yet. But what I do know is what triangles add up to. So if I can create some triangles in this, so for instance, right here, And right here, notice I've just created 3 different triangles, and I know all the angles here are going to add up to 180, all the angles here are going to add up to 180, and same thing here. So if I want to figure out what all the angles in total are going to add up to, I just need to add 180 plus 180 plus 180. So we'll say this is 5 sides here. What would be the sum of that? 180 times 3, or in other words, plus itself twice, would be 540. And what was our number of triangles here? That is just 3. Okay? So notice there's actually a connection here between these numbers, because notice this is just, or let's start with this. Notice here, this is just the same thing, or the amount of sides. If I just subtract 2, that's going to give me the number of angles. 3 minus 1, 4 minus 2, 5 minus 3. Okay, another pattern notice here is once we have the number of triangles, we just multiply it by 180. So 1 times 180 is 180, 2 times 180 is 360, right? We're just multiplying how many triangles we have by 180. And so this all leads us up to what we call the polygon interior angle sum theorem. Okay, or in other words, what do all the angles in any shape add up to? And it says this, it said the sum of angles in a triangle, okay, in a triangle will always be, and I'm going to kind of write this distinct because this is going to be kind of like a formula that we're going to use. I'm going to say n minus 2 times 180. Okay, I want you to circle that, underline it, whatever in your notes. Make sure that stands out. N minus 2 times 180. And I'm going to add on this little piece here at the end. I'm going to say with n equaling number of sides. Okay, n is just going to represent our number of sides here. Because notice if we take our number of sides and we subtract 2, we get the amount of triangles in there, and then we just need to multiply that number of triangles by 180. Okay, and this is how we find what all the angles in any shape add up to. We could go up to infinity. Doesn't matter. N minus 2 times 180. Okay, so practicing that a little bit here. Let's look at this one. It says we want to use that big theorem, or the polygon interior angle sum theorem, to find the measure of angle DAB. So I want you to sketch this for a second, and you can pause your video if you need to. Okay, and hopefully we have this sketch now. And if I'm looking at this here, I want to figure out what these angles are. Well, notice here, if I want to figure out what x is, or find the measure of angle DAB eventually, this one right here, I need to figure out what all the angles add up to. And so I see here I have 4 sides, 1, 2, 3, 4. So like we just said, we could just use our table for this one. I know these are going to all add up to 360. And if I didn't know that, or if I didn't remember that from the example, remember I could just do 4 minus 2 and then times 180. So now that I know all these add up to 360, now I can just put them in an equation because I know what all the angles are. I know one of them is x, another one is 3x, and then the two with the boxes, we've talked about that before, those are each going to be 90. So plus 90 and plus 90 here. And again, all these end up equaling 180. Okay, so now that we have this set up, now we just need to solve it. So I have like terms that I can combine. I have x and 3x, those combine to give me 4x. I have 90 and 90, those combine to give me 180. Oh, and I'm sorry, I messed up my equation here. So used to doing that with triangles. This should all add up to 360 here. Okay, make sure you're keeping track of what number they add up to. Okay, so equals 360 here. And then we can continue to solve. So next step, I would need to subtract 180 from both sides. When I do that, these would cancel, leave me with 4x. And then equals 360 minus 180. Well, 180 is just half of it, so 360 minus 180 is just another 180. Okay? And then last step here, divide by 4. And we get x equals 180 divided by 4. Okay, we can try to do this in our heads. 180 divided by 2 is 90, and then divided by 2 again is going to be 45. Okay, so x equals 45 here. But remember, that's not what the question was asking for. It's asking for the measure of angle DAB. So what do I need to do now? Well, we noticed DAB is right here, and we were told it's 3x. So all I need to do is plug that back in. So measure of angle DAB equals 3 times x, or in other words, 3 times 45. So final answer here, I'm going to get 3 times 45. We could do that in our heads or in a calculator, but that's going to give me 135 degrees. Okay, so this is how we use this theorem. We find out what all the angles add up to, and then it's similar to the problems that we saw with triangles. Okay, the big difference is that we're not just always adding them up to 180. Okay, another way that we can use this here, or another one to practice this a little bit. Let's kick it up a little bit, and let's say we don't have a quadrilateral. So again, I'll give you a second. I want you to sketch this, and I would make it decently sizable so that you have space for all the different expressions. Okay, so we have this here. We want to find x, so to do that, we need to figure out what all the angles add up to. And if we want to figure out what they all add up to, we can use that theorem. Remember, it's just n minus 2 and then times 180. So I need to figure out, first of all, what's in. How many sides are there? Well, there's 1, 2, 3, 4, 5, 6. So this is a hexagon. This would be 6 minus 2 and then times 180. So to figure out what they all add up to, 6 minus 2 is going to give me 4, and 4 times 180 is going to give me 720. So this is what they all add up to. They all add up to 720. Okay, now that I know this, I can just go ahead and add all these expressions together and add it up to 720. So I'm going to say x plus 2, I'll just go around here, x plus 2 plus x minus 4 plus x plus 6, continuing, plus x minus 3 plus x plus 7 plus x minus 8. Make sure you don't leave any out. And if I need to, I can count. I should have 6 total. 1, 2, 3, 4, 5, 6. Okay, we're all good. And then set it equal to that number that we found, 720. Okay, and now that I have this set up, I can go ahead and combine my like terms. So I see all these x terms, all of them are just 1x, and there's 6 of them. So I can just combine this to 6x here. And then the numbers, we're going to need to do a little bit more calculation here. We have 2, negative 4, positive 6, negative 8, positive 7, and negative 8 here. So I'll just take this one at a time. 2 minus 4 is going to give me negative 2. Plus 6 is going to give me positive 4. Minus 3 is going to give me positive 1. Plus 7 is going to give me positive 8. And then minus 8, crazy enough, that's just going to give me back to 0. So this is either plus 0, or the good news is since it's just plus 0, they all cancel each other out actually. Okay, it might not look that way, but interestingly enough, they actually do. So those cancel each other out, so I'm just left with 6x equals 720, and then last step here, divide by 6. And I'm going to end up with x equals 720 divided by 6. Again, we could just type this in our calculators if we don't know, or a good mental math practice. It's kind of just like 72 divided by 6, and then add a 0. That would give you 120. Okay? So I know I kind of rushed through those a little fast, but this is how we use these theorems, because we've done all these problems before, except we were just always adding the angles up to 180. Now we need to find this number, and then same kind of thing, add them up and solve. Okay? So that is for the interior angles. Other things that we can talk about as well is what if we talk about the exterior angles? Okay, remember we've seen these before. We talked about these when we talked about triangles in general, and we had some different things that we talked about with them, you know, how to find them and so on and so forth. So notice here, we could double check this first example just to make sure this is correct. I see a linear pair, so this would be 60, this would be 80, and this would be 40 here. And if I add all the angles on the inside, we've talked about that, that's going to be 180. Well, I notice I have my angles on the outside here, and this one's a little bit simpler. I don't need to find out how many triangles are in this because they're on the outside. So all I'm going to do is I'm going to add them up. I'm just going to say 120 plus 100 plus 140, and let's see if we can find a pattern here. So 120 plus 100 is 220, and then 220 plus 140 is 360. Okay, so in this case, they all add up to 360. Okay, and that's for a three-sided shape. Okay, let's see if we can do the same thing over here. So I have 105, 40, 110, and 105 again. So I'll add all those up. 105 plus 40 plus 110 plus 105 here. Same as always, you can type this into your calculator if you want. But just a little mental math practice. 105 plus 40 is going to give me 145. Add another 110, that's going to be 255. And then 255 plus 105 is going to give me 360. So we notice we get that same number again. They add up to 360. And now let's check this last one here. We have, and these ones are a little bit tougher because they're not as round of numbers, but we have 65, 98, 36, 50, and 111. So I'll go ahead here, plus 98, plus 36, plus 50, and plus 111. So I'm just seeing what they all add up to. Again, I could type this into a calculator. I'll save you the time on this one. This is also going to come out to be 360. So simple enough, this leads us to our other theorem, polygon exterior angle sum theorem, or in other words, a simpler way to say this is what do all the exterior angles add up to? And I can say this, the sum of the exterior angles will always be 360 degrees. Okay, so this one's much easier. I don't care about how many sides there are. There could be 3 sides, there could be 10 sides, there could be 100 sides. No matter what, the exterior angles are always going to add up to 360. Okay, so it makes it a little simpler for us. All right, so putting this into practice for our last one here, I'll give you a sec if you'd like. I want you to go ahead and sketch this diagram here. Again, make sure you give yourself enough room to include all the expressions. And now that I'm looking at this here, how would I solve for x? Because all it wants me to do is find x. Well, notice it's the same as before. I can add them all up, and we just talked about this. I can add them all up to 360. So I'm going to say 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x plus 5x. Make sure you include all of those here. Okay, all of them are going to equal. Doesn't matter how many sides there are. Even though there's 5 sides, it doesn't mean it's going to change that. It's still going to add up to 360. And now, same as before, I can just go ahead and solve. So I can combine my like terms here. So I have 2x, 3x, 6x, 2x, and 5x. So 2 and 3 is 5, 5 and 6 is 11, 11 and 2 is 13, and 13 and 5 is 18. So 18x. Plus here, I can combine the numbers as well. I have a few of these, -5, +10, -5. Something we notice here, this actually ends up being the same kind of idea that we saw with the last problem. The numbers actually all cancel each other out. So I can just put +0, or I don't even have to put that. I can just put equals 360. And now, same as before, just divide by 18. When I do that here, I get x equals 360 divided by 18. And you could, again, type this into a calculator or mental math practice, but this is going to give you 20. So x equals 20 here. Okay, notice this is all I was asking for. I double check. I don't need to plug it back into anything. Okay, so these are the 2 ideas. Do I know how to find what all the angles inside a polygon, I was about to say triangle, inside a polygon add up to? And then do I know that all the outside angles, no matter what, are going to equal 360? Okay. Assignment for today is 7.1, angles of polygons, and that should be posted on the class website. As always, if you guys have any questions, feel free to let me know. All right, thanks guys.